Hello everyone. Today we are going to discuss the equation of real straight line and complex straight line, and after that we go for how to define slope of real line and then slope of complex line, and finally we will discuss the condition for parallelism and perpendicularity. Let us start. First, equation of line in real system. We know that equation of straight line in general that can be written as px plus qy plus r equal to 0, where p square plus q square not equal to 0 and p comma q comma r, they are real values. P square plus q square non-zero means at a time both p comma q non-zero quantities here. In case at a time both p comma q are zeros, then r equal to 0 we get. It is not a straight line. And remember, p comma q comma r any real values. You know all this. Now let us move to complex straight line. To write the equation of straight line in complex form, I am going to choose, suppose z equal to complex number in general x plus iy. If z is x plus iy, then its conjugate written as z conjugate equal to x minus iota y. Now adding z and z conjugate, what we get observed from these two, if I add z and z conjugate, here iota y, negative iota y become cancelled and only we get x plus x, that is 2x. Suppose if you subtract z conjugate from z, then here x and x gets cancelled, iota y minus of minus iota y become 2 times of iota y, 2 iota y this is. So that from this you can write real part of zx, that is z plus z conjugate divided by 2. Real part of z, that is x, written as z plus z conjugate divided by 2, and here imaginary part of z, clearly that is y, written as z minus z conjugate whole divided by 2 times of iota. Now replace x with z plus z conjugate by 2 and y with z minus z conjugate by 2 times of iota, then it reduces to complex form. Let us move on substitution. P times x value z plus z conjugate divided by 2. Next q times the value of y, z minus z conjugate whole divided by 2 times of iota plus r equal to 0. Now if I take z common, then inside we get p by 2 here, and here it is q divided by 2 times of iota. Next, if I take common z conjugate, inside here we get p by 2 and here minus q divided by 2 times of iota plus r equal to 0. In the next step, what I am doing, observe z multiplied by p by 2. Here multiply with I and divide with I. Iota in the numerator, iota in the denominator part if I write, denominator part 2 times of iota whole square, that is minus 2. So you can write minus I q divided by 2. Next plus z conjugate. Here negative unity written as I square. I square divided by I, simply I. So that we get P by 2 plus I q by 2 plus R equal to 0. Here P by 2 minus IQ by 2, P by 2 plus IQ by 2 are conjugate to each other and both are in complex form. Let us suppose this is complex vector, suppose A. It can be written as A conjugate and here multiple Z. Remaining plus R, it is equal to 0. Here Z, Z conjugate, A conjugate, they are complex numbers. They are in complex form and R only the real. And this is equation of straight line in complex form. Z A conjugate plus Z conjugate A plus R equal to 0. And remember, here in this case, A is written as P by 2 plus iota Q divided by 2. This is A. And also, I can say that P by 2 is clearly real part of complex number A. And Q by 2, that is imaginary part of complex number A. This is about real straight line and complex straight line. Now let us move to slope of real line and complex line. You know that if suppose a straight line makes an angle theta with positive direction of x-axis in the counterclockwise sense, then tangent angle is known as slope of real straight line. But in case of complex slope, it is square of unimodular. Let us discuss first real slope and then go with complex slope. Suppose if a straight line that makes an angle theta with positive direction of x-axis in the counterclockwise sense, that is the diagram. There is a straight line L equal to 0 that makes an angle theta with positive x-axis in the counterclockwise sense. Then slope is defined by tangent angle and it is usually denoted by M. This is about real slope, definition of real slope. Next, we go for complex slope. Complex slope is square of unimodular of given Z. Suppose this is a complex number Z, complex vector OZ. Then square of unimodular, square of unimodular of Z means unit vector of Z, that is Z by modulus Z, and it is complex slope denoted by mu. This is the basic definition of complex slope. And also you can write mu as, here Z square written as Z into Z. In the denominator part you have mod Z whole square, that is mod Z into mod Z. Suppose if you multiply with Z conjugate in the numerator and in the denominator part, on simplification it is, first Z as it is I am going to write in the numerator, Z into Z conjugate written as mod Z whole square, that is mod z into mod z divided by denominator part mod z z conjugate. Modulus z whole square in the numerator and denominator part gets cancelled. Finally, it becomes z by z conjugate. Complex slope also defined by z by z conjugate. This is about complex slope, or simply we can say that square of unimodular. This is square of unimodular, that is square of unit vector, that is complex slope. And let us see, if suppose real line is of the form px plus qy plus r equal to 0, you know that real slope written as minus p by q. And if the equation of line, suppose in complex form z into a bar plus z bar into a plus r equal to 0, then what is complex slope? Let us discuss. Yes. And then we go for condition for parallel and perpendicular lines also. First, see the relation between real slope and complex slope. First, in the real system, equation of line, suppose px plus qy plus r equal to 0, then we know that real slope equal to minus coefficient of x divided by coefficient of y. This is the real slope, and real slope is usually denoted by m minus p divided by q. And just now we discussed here p is 2 times of real part of a, q is 2 times of imaginary part of a, so that I can change numerator as 2 times of real part of a, q that is 2 times of imaginary part of a. Therefore, real slope also you can write minus real part of a divided by imaginary part of a. This is about real slope. You can write minus p by q or minus real part of a by imaginary part of a. This is in complex notations. The same equation in complex form written as a z bar plus a bar z plus r equal to 0. Now what is complex slope? Let us discuss complex slope. Both the equations represent the straight line, same straight line, px plus qy plus r equal to 0. You know that since tan theta is slope denoted by minus p divided by q, tan theta minus p by q, I can write from this sin theta divided by cos theta equal to minus p divided by q. Next, what I am doing, observe. If I write numerator cos theta plus I sin theta and denominator part cos theta minus I sin theta, in the right hand side I can write minus q plus I p. Sin theta minus, suppose cos theta equal to minus q, sin theta ip. Cos theta plus I sin theta, now minus q plus ip you can write. This p here I am going to use this minus sign, not P. Suppose this minus sign is for Q. Minus Q plus IP I can write. Next, divided by minus Q minus IP. Also I can write suppose minus 1 negative unity is iota whole square. Minus 1 I am going to write iota square. Negative unity suppose I square. You can write I square Q plus IP divided by I square Q minus I cube P. Now, or simply put IP as it is. Only this negative unity is iota whole square and this negative unity iota whole square. If you take I common, then what happens, observe. In the next step I can write this as cos theta plus I sin theta divided by cos theta minus I sin theta become, if you take I common, what we get? P plus IQ. In the denominator part if you take I common, or minus I if you take common, P minus IQ. Neglect iota in the numerator and denominator part and divide each term with 2. P by 2 plus I Q by 2, negative sign outside, P by 2 minus I Q divided by 2. Iota neglected in numerator and denominator part and divided with 2 each and every term. Why this cos theta plus I sin theta and cos theta minus I sin theta written? Let us observe in the next step. You know that complex slope is square of unimodular. Unimodular, that is unit vector along given z. Usually unit vector along z written as simply cos theta plus I sin theta e power I theta, that is unit vector along given complex number z. Here if you observe, numerator become e power I theta, denominator part become e power minus I theta, so that on simplification it become a power m divided by a power n formula. If I use a power m plus n, a power m minus n, finally it gives the result e power I 2 theta, that is e power I theta whole square. This one, this cos theta plus I sin theta by cos theta minus I sin theta. Now this is clearly square of unimodular. So you can write the symbol mu and observe here, negative sign you have outside. Next, P by 2 plus I Q by 2. P by 2 plus Q by 2I, that is clearly complex number A. So that minus A divided by A conjugate. This is complex slope of given line A into Z conjugate plus A conjugate into Z plus R equal to 0. Complex slope mu equal to minus A divided by A conjugate. This is about real slope and complex slope. Next, move to condition for parallel and perpendicularity. In the real number system, you know that when the two lines are parallel, then their slopes are equal. Suppose that two straight lines are parallel. Automatically angle of inclination theta 1, theta 2, they are equal. Suppose this is positive x-axis. When the two lines are parallel, angle made by these two lines with the positive direction of x-axis in the counterclockwise sense is same, so that I can write theta 1 equal to theta 2, applying tangent angle on both the sides, tan theta 1 equal to tan theta 2. Therefore, you can write m1 equal to m2. This is in the real system. Let us move to complex form. In complex system, since tan theta 1 equal to tan theta 2, now you can write sin theta 1 divided by cos theta 1 equal to sin theta 2 divided by cos theta 2. By ratio proportion, if I write cos theta 1 plus I sin theta 1 divided by cos theta 1 minus I sin theta 1 in the left hand side, by ratio proportion it is equal to automatically cos theta 2 plus I sin theta 2 whole divided by cos theta 2 minus I sin theta 2. You know that they are unimodulars. First one here, e power I theta 1 divided by e power negative iota theta 2. Right part, numerator e power iota theta 2 divided by e power negative iota theta 2. On simplification, it become left hand side square of unimodular, we get e power I theta 1 whole square it is, and this is e power I theta 2 whole square you can write. E power 2I theta 1 left hand side, right hand side e power I 2 times theta 2. Rewriting in this way, and this is clearly definition of complex slope, so that mu 1 equal to mu 2 is the condition for parallel lines in complex form. Let us move to perpendicularity. You know that if two lines are perpendicular in the real system, product of slopes become negative unity. You know this. See here. Suppose the two lines are perpendicular and they are not horizontal and vertical, remember. There is a straight line, first one, and suppose that this is another straight line. L1 first line, L2 second line it is. Suppose that theta is angle between two lines, and this is theta 1 and this is theta 2. External angle theta 2, that is written as theta 1 plus theta, sum of two opposite external angle equals sum of two opposite internal angles. Theta 2 written as theta 1 plus theta. Next, and from this theta written as theta 2 minus theta 1, applying tangent angle on both the sides, you know that tan theta equal to tan A minus tan B. Tan A minus B formula in the right hand side, 1 plus tan A tan B. Since theta is acute, you need to write modulus sign, and you know that angle between lines tan theta, you can write m1 minus m2 by 1 plus m1 m2. It is acute angle between the lines. When the lines are perpendicular, that is theta when it is of 90 degrees, you know that theta 90 degrees implies it is tangent angle at theta equal to 90 degrees. It is not defined. Possible only when denominator part equal to 0. Denominator part 0 means m1 into m2 plus 1 equal to 0. That implies simply I can write product of slopes equal to minus 1. Yes, this is in the real number system. Now let us move to complex form. Since tan theta 1 multiplied by tan theta 2 equal to negative unity, I can write tan theta 1 equal to minus of 1 by tan theta 2. Also you can write tan theta 1 equal to minus of cot theta 2. Also I can write tan theta 1 value equal to, you can write this as tan of 180 minus theta 2. In the second quadrant, tan negative, it is pi by 2 plus theta 2. For 90 plus theta, it changes to cotangent angle. 90 plus theta second quadrant. In the second quadrant, tangent negative. Yes. Neglecting tangent angle on both the sides, theta 1 written as pi by 2 plus theta 2. Right? Now, iota theta 1 equal to iota pi by 2 plus iota theta 2 you can write. If I multiply with 2, iota 2 times theta 1, iota pi, multiplying with 2 on both the sides. If you apply base e power I 2 theta 1 equal to e power I pi multiplied by e power I 2 theta 2, this is a power m into a power n, in the right hand side a power m plus n, that is e power iota pi plus iota 2 theta 2. This is clearly square of unimodular u1 mu 1 and this is mu 2. E power I pi written as cos pi plus I sin pi. You know that sin pi value 0 and cos pi value minus 1. So just we get here, actually it is cos pi plus I sin pi, but we get sin pi value 0, cos pi value minus 1, so that minus 1 multiplied by mu 2. So that finally you can write mu 1 plus mu 2 equal to 0. So this is a condition for perpendicularity. When the two lines are parallel, m1 equal to m2 and mu1 equal to mu2. When the lines are perpendicular, in real system, m1 into m2 equal to minus 1. That is, one slope is negative reciprocal to other. But here, the combination of two slopes become 0. That is, mu1 plus mu2 equal to 0 is the condition for perpendicularity, remember. This is about real straight line, complex straight line, and how to convert real slope into complex slope, and the condition for parallelism and perpendicularity. The students, those who are watching my videos, please share my videos and subscribe the channel. Thank you so much.